Okay, so the first thing we need to do is connect the robot to the controller. Here is the gigantic connector, and then that has to go on the back of this right there with this guy. And so what we got are these huge cables that have a screw in the middle that let you attach it securely, and God forbid you bend one of them pins. But this is what we got, however many pins that is. Okay, so you can see we got our power cable connected. You tighten this bit down to compress it all together and keep all those pins aligned. Then come around to the back, you can see we got that going. So now we got to connect, the next step is to connect our floppy disk drive. And we'll show that turn on in a bit, but this is what stores the programs, but also loads the operating system, called VAL. And for our purposes, there's a serial connector on here, but we don't seem to need it. Baud rate is switchable between 2400 and 9600. That's the bits per second. So that'd be 9.6K for those doing the math. And then power switch, and I'm not sure what this one's about, but it was up when we got it. We left it up and it worked. So now, for whatever reason, they decided to use these funky 10-pin connectors for everything. But we can see back here, that we need to connect it to the floppy disk, and they're keyed, so they only go in one way. You tighten that guy on down. So now we'll connect our power cable, which we got here. And since these are meant for heavy use in machinery, they're actually keyed and they rotate once you get them on there, so that they can't just be yanked out. So you gotta find the key here and then rotate it over. Now that thing can't come out. And we got our power. We'll plug in a few minutes. And then we have this interesting stop switch. And so this is like an e-stop that you can hold in your hand while you're working the robot. If it's about to crash, boom, you can stop it. It's the same as this arm power switch. And again, it's a binary switch, but they wanted to use the same 10-pin connectors for everything apparently on this. So then we put this guy into the arm power port here. And once again, keyed. So the two wires that are actually being used will be oriented correctly. Next, we got to connect it to our actual terminal. We don't have a terminal. The one we bought isn't working. I'm going to get it working, but for now we're using a computer running Linux. And so we got to connect this guy, which is RS-232, but they just created their own. They just decided we'll connect whichever pins we feel like connecting to whichever pins we feel like connecting. Luckily, the people at RP Automation were kind enough to provide the pinouts, so we know how that serial connection there corresponds to a standard RS-232. Actually, this thing is already hooked up when we got it, so luckily it works with the terminal, the Linux terminal. Oh, and then this, yeah, they knew that you'd want this guy frequently, so being thoughtful people, they give you a little bit of Velcro on the front there. Last but not least, we have to hook up our controller/teach pendant. That's another one of these 10-pin connectors, and this guy goes right on the front here. Okay, next we got to hook up our shop air from the other room here. So we throw our fitting on there. We're going to run that line full of air out to the other room to power the pneumatic gripper. That's the basics of getting the things connected together. Now we got to connect the terminal/computer. Okay, so as you can see, these sectors have all loaded. Copyright 1981. This is actually Val 2. This is the second edition of this software. This is February 86. but I believe that these Puma arms came out in about 1978. Might have been a year or two earlier. Okay, so we're ready to initialize. Are you sure? Yes. Okay, so we heard the disc make sound. Okay, now it says arm power off. So now we got to come over here. We got our power on, but here's our arm power. Now we're in comp mode. What we're gonna do is just run an initial test and make sure that the arm goes up into what's known as its ready state.
Well, we have to calibrate first. Then we can test, then we go ready. So when you first turn on the arm, it doesn't know where it is. So that's why it has this little holder here that holds the arm in place. And so we're gonna tell the robot that it's in the holder by running cal.
Here, let's release the brake and pull it out of the holder.
Yeah. So once you flip the brake release switch here, you can press this little button on the side, and this causes the whole robot to go limp, so you can move all the axes manually.
It actually has brakes that are fail-safe, so they have to be powered on for you to be able to move the robot at all. We'll turn arm power back on,
Yep.
and it's not going on.
It's not.
Fatal error. Is that a restart?
Yeah, we're just gonna reinitialize. We're not gonna restart the whole thing. So there's this switch for initialize. It's a toggle switch, so we're just gonna do that. And now we're gonna get a load valve, but we're not going to reload it from floppy because it's already in internal memory.
So there's the switch on the back here.
Yeah, so now the robot's limp here. We're going to get it into its nest position.
It has a little
securely.
pin that lets you know when you're in the right place in there.
Yeah, now we're gonna hit record. And now the robot's locked in position.
Okay, now we're gonna run the calibration. You can see it just moved each joint a little bit to make sure they're all functioning.
Well, no, it's actually moving them until it hits the encoder index position.
Oh, okay.
Because the encoders, they give like a pulse every, I don't know, 1/300th of a revolution, but when they make a full revolution, they have a third pin that gives out an additional pulse called the index pulse. So it's actually moving every joint until it sees that index pulse, because that index pulse is in an absolute position rather than a relative.
Oh, so it does know its absolute position.
It does now. Yeah.
Okay, excellent. Okay, so now we should be able to do the ready position. And there it is. On this gripper, you can see it's just hard little aluminum brackets. So we're gonna put a little foam on there to make it compliant so it can pick up what we want it to.